So the textbook, the pre-calculus book, is very similar to the trig book. So if y'all notice, because the QR code's in the trig book where you could scan it, this has the same thing. Now there's a reason that this book is twice as thick as the trig book. It's because calculus is considered a full year course. Trig's only half. So there's a lot more in it. Now we're not going to cover everything in the book because there's a lot of stuff that the trig book we already covered. We're not going to cover again. But the first thing we're going to look at is the Cartesian plane. So just remember, real numbers by points on a real number line, you can represent ordered pairs of real numbers on a plane called the rectangular.
Kayla Butler, come to the office. Kayla Butler, come to the office.
Coordinate system, or the Cartesian plane, named after the French mathematician René Descartes. So, two real number lines intersect to form the Cartesian plane. This here. First, second, third, fourth, it goes around counterclockwise. In the first quadrant, we have the positive x, positive y. In the second quadrant, we have the negative x, positive y. In the third quadrant, we have the negative x, negative y. And in the fourth quadrant, we have the positive x and negative y. Points of intersection is usually called the x-axis and y-axis. 2 points of intersection where they cross is the origin. And these divide, the two axes is divided into 4 parts called quadrants. All right. X-coordinate goes first. Tells us the distance away from the y. And the y-coordinate represents the direct distance away from the x-axis. And we give it an ordered pair, x, y. Our first example is we're going to plot these points. So if we look at the point, we'll call it point A, negative 1, 2. We'd go over to negative 1, up 2, and make a point, we'll call it A. 3, 4, our next point, we can call B. So we'd go over to positive 3, and up 4. That's it. Our next point is the point 0, 0. That is the origin. Three, 0. We'd go over 3 on the positive x-axis, and we wouldn't go up anywhere. Our last one, negative 2, negative 3. Do you feel comfortable plotting points? That's our solution. The beauty of a rectangular system is that it allows you to see relationships between two variables in a visual way. All right. The following famous theorem is used extensively throughout this course. Pythagorean theorem, a squared plus b squared equals c squared. For right triangles. Now, interestingly enough, and this is actually kind of interesting, suppose you want to determine the distance between 2 points, x1, y1, x2, y2. What we can do is set it up as a triangle. So if I want to know the distance from this point here to this point here, this distance d, well, we set this triangle up. Now this distance is this value of y2 minus y1. That's just how we find the distance of a straight line. Same thing here with x2 minus x1. So side length A really can be defined as y2 minus y1. And we could say that B is x2 minus x1. So therefore, actually, I'm going to write this out. We could say that our a squared plus b squared equals c squared. A is our absolute value of y2 minus y1 plus our x2 minus x1. And both of those are being squared. Now, what's interesting with this here is because we have absolute values in squares. Because the absolute values didn't take the positive value, we'll have a positive case. But if we square something, it's also going to be positive. So really, we don't need both the absolute value bars and the square. We can get rid of the absolute value bar. Is equal to our distance squared. But I don't want to know what the distance squared is, I just want to know the distance. And to find that, we can take the square root which is actually our distance formula. So actually using the quadratic formula, we can find our distance formula. Is this here? So the next thing we're going to do is use the distance formula to find the distance between 2 points. So our distance formula, y2 minus y1, we take our two y values and square it and add to it the difference of our two x values and square it. And at this point here, we can type the whole thing into the calculator, let it do it for us.
I need Darley DeHoyes and Nicole Powell to come to the office.
Or we can do this by hand. 4 minus 1 is 3. 3 minus negative 2. Negative negative makes a positive. 3 squared is 9. 5 squared is 25. Which gives us the square root of 34. Which is actually just square root of 34. Or we can approximate it to 5.83. So the distance between the 2 points is about 5.83 units. Use the Pythagorean theorem to check. And we can see that it is true. Questions on distance? Midpoint. To find the midpoint, the middle of a line, we use the midpoint formula. x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So if I wanted to find the midpoint of this here, we're just going to use this here. So we take our x values and add them together. So we'd have negative 5 plus 9 over 2, comma, negative 3 plus 3 over 2. Now at this point here, we don't have to do any of this by hand. We could do this all in the calculator because negative 5 plus 9 over 2 is 2. And our other value is negative 3 plus 3. Well, what is negative 3 plus 3? 0. Yep. And divided by 2 would be 0. So the midpoint is questions on this here. 2, 0. If we wanted to plot it, we'd see that it is indeed the midpoint. That's it. Yes. Yeah, this first chapter is essentially Algebra 1 revisited. So 9 through 12, all you're doing is determining which quadrant would the point or sets of points lie. And then doing these